Hi friends, welcome to SankalpStudySuccess. In this video, I am going to explain about in discrete mathematics there is a concept called non-homogeneous recurrence relation for r to the power of n value. Okay, so in the previous sessions I discussed about for constant and discussed about for n values. Okay, so this is for if f of function value is r to the power of n, then what will be the solution for that particular non-homogeneous linear recurrence relation. Okay. See the first question here, an equal to 3an minus 1 plus 2 to the power of n with the initial value a naught equal to 0. Okay, as you know that what will be the non-homogeneous recurrence relation function, it should be in the form of an is equal to an to the power of h plus an to the power of p. Okay, so we just split into this particular recurrence relation into homogeneous as well as particular value. So in this recurrence relation, in this linear non-homogeneous recurrence relation, what is the homogeneous function? That is an to the power of h is equal to what? An minus 3an minus 1 equal to 0. Right. What will be the an to the power of p particular value? That is 2 to the power of n. Right. Here the function value, in the form of r to the power of n. Okay. So there is a separate general function for this particular notation. Right. So here an is equal to 3an minus 1 equal to 0. First solve this particular homogeneous and then solve this particular function and then combine these two, substitute these two values here, then we will get the an value. That is the process for every non-homogeneous recurrence relation. Okay. So see the solution first. An to the power of h is equal to what is that? An minus 3an minus 1 equal to 0. Okay, so convert into our form, that is r to the power of n minus 3 r to the power of n minus 1 equal to 0 and divides by the smallest power. What is the smallest power here? R to the power of n minus 1. So that we will get r minus 3 equal to 0. So that here we got r equal to 3. So here we got only one root value 3. Why? Because it is the first order linear recurrence relation. You see that here. What is the biggest one? Subscript n. What is the smallest one? N minus 1. If you see this n minus 1, if you cancel n, minus into minus plus 1. Okay, so what is the order of this particular linear recurrence relation, ma? That is 1. That means it is what? First order linear non-homogeneous recurrence relation. Okay. So for homogeneous recurrence relation, what is the, for first order, what is the general function? Okay, you see, for first order homogeneous recurrence relation of general function is an equal to a into r to the power of n, a simple form. Okay, here a into r to the power of r value is what? 3. So 3 to the power of n. Okay, so here an is equal to what is the value? A into 3 to the power of n. Keep aside, this is a first equation. Okay, and now we need to find out the particular value. Okay, that is what is the particular value? An to the power of p, that is equal to what? 2 to the power of n. Right, it is in the form of r to the power of n. R to the power of n is equal to 2 to the power of n. That means r is equal to what is the value? 2. Here you must know the general function for r to the power of n, and you need to write here the statements called in this particular function, the function is in the form of r to the power of n. Okay, so the solution could be a n to the power of p equal to a into r to the power of n. Okay, the same solution what is for the first order, for r to the power of n, the same solution. Okay, so a n to the power of p is equal to what is the r value, ma? Here 2, right? So simply a into 2 to the power of n, this is our second equation. Now combine these two equations. So sorry, here first we need to find out the a value. How you can find out the a value? With the help of the first equation. What is that? an equal to, that is an minus 3an minus 1, okay, equal to 2 to the power of n. This is our recurrence relation. So substitute this particular equation in this equation so that we got a value. After that combine. Okay, first we need to find out the a value. So to obtain the a value, substitute this value in the given recurrence relation. Okay, so here a into 2 to the power of n, that means a into 2 to the power of n minus 3 into a n minus 1. In the place of n, what is there? N minus 1 is there. So you need to put 3 into a into 2 to the power of n minus 1. Okay, and equal to 2 to the power of n. Okay, now no need to substitute in the right hand side part. Okay, we have to substitute in the left part only. Then what is the smallest superscript here? That is n minus 1, right? n minus 1 and n. So here we need to divide by 2 to the power of n minus 1. Okay, it should be divides by 2 to the power of n minus 1, so that we will get a into 2 to the power of n by 2 to the power of n minus 1. That means what? See, I'll write here the rough work. 2 to the power of n by 2 to the power of n minus 1 means a power m by a power m minus n. So n minus n cancel and minus into minus plus 1 will get 2, right? So 2 minus 3 into a into 2 power n minus 1 by 2 power n minus 1, 1 only. So minus 3a equal to, here 2 power n by 2 power n by 2 power n minus 1. The same thing. Here we got 2, right? Then 2a minus 3a, what is that? Minus a equal to 2. So what is the a value? Minus 2. So you got the value a equal to minus 2. So substitute this value in this second equation so that we got the particular equation. Okay, substitute an value in the particular equation, that is a into what is that? 2 to the power of n, right? 2 to the power of n. So here minus 2 into 2 to the power of n is our particular equation. Okay, now we have to combine the fourth equation and that particular homogeneous equation. Where it is? So see here, a n to the power of h, a n to the power of h is a into 3 to the power of n. Combine these two. Okay, so that now combine fourth equation and second equation. So a n equal to, what is the value? So here this is the a n equal to a n to the power of h, this one, a n to the power of p, this one, right? So here we need to obtain the a value. How do we get the obtain the a value? With the help of the initial condition, right? So what is the initial condition there? Check the question once. With a not equal to 1. Okay, so here for a not equal to 1, that means what? N equal to 0. So put n equal to 0 in this equation, so that a not equal to here a into 3 to the power of 0 plus minus 2 into 2 to the power of 0, right? So a not value is equal to 1 and a into anything power 0 1, okay, plus minus 2 into anything power 0 minus 1, sorry 1 only. So minus 2 into 1, 2 ones are 2 and minus, so here we got minus 2. Okay, and finally 1 equal to a minus 2. So a equal to 1 plus 2, that is 3. So don't be confused. This a value for homogeneous, that a value for particular value. Okay, so here both the a's are different. Here the a for homogeneous and here also a for particular value. So finally what we got? A n equal to 3 into 3 to the power of n plus minus 2 into 2 to the power of n, right? This is our required solution for that particular non-homogeneous recurrence relation, right? So like this we have to do. Clear ma? So hope you understand. This is for first order. Okay, what about second order? Like this you will get for second order, third order. Okay, so see this example, second order. an equal to 5an minus 1 minus 6an minus 2 plus 7an. That means what? Here the linear equation an minus 5an minus 1, I will do the solution here, minus plus 6an minus 2 equal to 7 to the power of n. Yes, it is a non-homogeneous because there is no equal to 0. Okay. So, need to split into this into two parts, that is a into the power of h and a into the power of p. Okay. Now, so what is our required solution? An is equal to a into the power of h plus a into the power of p. So, what is the a into the power of h? What is the homogeneous recurrence relation here? An minus 5an minus 1 plus 6an minus 2 equal to 0. Okay. Now, what is the particular equation? An to the power of p is equal to 7 to the power of n. Okay. So, it is in the form of this function. This function in the form of r to the power of n. Okay. So, if it is r to the power of n, what is the function for particular value? That is a into r to the power of n. Okay. That is the secondary. First, solve the homogeneous recurrence relation. Okay. So, convert into our form r to the power of n minus 5 r to the power of n minus 1 plus 6 r to the power of n minus 2 equal to 0. Then divides by, it should be divided by the smallest superscript, that is what? R to the power of n minus 2, r to the power of n minus 2. Okay. So, that we get r square minus 5r plus 6 equal to 0. So, here we got ax square plus bx plus c equal to formula. So, with the help of the root method, so you can find out the roots here, right. So, we will got here r square. So, can we write r minus 3 into r minus 2 equal to 0? Directly I write here, but better you do r equal to 3 and r equal to 2, right. R1 and R2 values, R1 equal to 3 and R2 equal to 2. So, here we got distinct real roots, not repeated. So, this is the second order homogeneous, the first case is second order homogeneous recurrence relation, and that too second order homogeneous recurrence relation, and that too distinct real roots. Okay, distinct real roots. So, what is the general function for distinct real roots in the second order? That is an equal to a into r1 to the power of n plus b into r to the power of n, right. A into r1 to the power of n plus b into r to the power of n. Then the homogeneous, the particular homogeneous relation will be a into r1 value 3 to the power of n plus b into r2 value 2 to the power of n. Okay, this is our, let us say this is our first equation. Okay, and this is our second equation, and next, because we need to combine, right. So, this is our third equation. So, this is our homogeneous recurrence relation solution. Now, what we have to do? We need to obtain particular value. We need to obtain particular value. So, that is what? An to the power of p equal to, what is that? 7 to the power of n, right. So, here f of n is equal to what? 7 to the power of n. That means r to the power of n. That means r is equal to, what is the value? 7, right. So, see here, what is the general solution for this? The general solution could be a into the power of p is equal to a into r to the power of n. That means a into 7 to the power of n. This is a solution. Okay. Next, take this one as a 4. Now, here we need to obtain the a value. So, to obtain the a value, or to find out the a value, okay, equation 4, substitute in equation 1. Substitute in equation 1. So, what is our equation 1? That is an minus 5an minus 1, okay, and then plus 6an minus 2 equal to 7 to the power of n. This is our first equation. So, substitute a into 7 to the power of n in this equation. Okay. So, the first term an. So, simply a into 7 to the power of n. minus 5 into a in the place of n minus 1 is there. So 5 into a into 7 to the power of n minus 1, okay, plus 6 into a into, in the place of n what is there, n minus 2 is there, so 7 to the power of n minus 2, okay. Here in this equation this is in the subscript, okay, but our particular equation 7 to the power of n, so substitute this value here, okay, so equal to 7 to the power of n. Now divide by, it should be divides by, what is the smallest one, 7 to the power of n minus 2, so both sides better to divide by 7 to the power of n minus 2. So after that we get a into, you see that 7 to the power of n by 7 to the power of n minus 2, 7 to the power of n by 7 to the n minus 2, that means what, n minus 2 plus 2, so cancel 7 square, that means what, here we got 7 square minus 5a into, directly write the statement ma, okay, 5a 7 to the power of n minus 1 by 7 to the power of n minus 1 by 7 to the power of n minus 2, that here we got 7, okay, a to the power of m by a to the power of n formula, a power m minus n plus 6 equal to 7 square, okay, so that 7 7s are 49a minus 7 5s are 35a plus 6, I think here we have a, right, yeah, a equal to 7 square, 7 square is the, what is the value, 49, right, so 49 plus 6, 54, 49 plus 6, 55, I'm sorry, 55, right, so 55a minus 35, what is the answer, 20a, 20a equal to 49, so that a is equal to, what is the value, 49 by 20, this particular a value, where it is, in particular value, okay. Now we have to substitute this value in, now substitute a value in the particular equation equal to, that is a into r to the power of n, that means 49 by 20 into 7 to the power of n, this is our particular equation ma, okay. What is the equation number, 4 and 5, this is the fifth equation, okay. So what is the homogeneous recurrence relation function, where it is here, third equation, okay. Now combine these third equation and fifth equation, okay. Now combine third and fifth equation, okay, so that we will get, because that is the a into the power of h plus a into the power of p, so a n equal to, what is that value, a into 3 to the power of n plus b into 2 to the power of n plus 49 by 20 into 7 to the power of n, right, that's it. This is our required solution for non-homogeneous recurrence relation if they have given f of n value r to the power of n, okay. So in the given relation they have given any initial condition, no, there is no initial condition here, so we should stop here. If there are any initial condition there, again with the help of those initial conditions you need to obtain a value and b value ma, okay. So actually you need to stop here because there is no initial conditions in the question. In case meeku exam lo initial conditions iste, for a not equal to value, for a1 equal to value ani n value substitute chesi a and b values ni meer find out cheyali. You need to find out a and b value and substitute a and b values in this equation, and finally that is our required equation, okay. Hope you understand this concept clearly. So you see here, as of now in non-homogeneous recurrence relation, I complete f of n is equal to c constant is completed, f of n is equal to n is completed, and f of n is equal to r to the power of n is completed, this video, okay. And the last method in the non-homogeneous, that is f of n is equal to n square, okay. So that is our next video, okay. I will do that next video. Thank you for watching. Do subscribe to our channel Sankalp Study Success.